over 2. So first off, what is the circumference of the whole circle? Anyone?
Isn't it 2 pi?
It is 2 pi. Since the radius is 1, the circumference is 2 pi times 1. If I divide by the radius of 1, I still get 2 pi. So 2 pi is also the radian measure of the entire circle. I'm not going to draw that right now because it's going to look really ugly. So the whole circle measures 2 pi. So now if we're right here at pi over 2, there's 2 different ways you can do it. You can make your fraction theta over 360 and multiply it by 2 pi. Does anyone know what the theta measure is for this angle right here from here to here?
$45. Wait, what are you asking?
From here to here, not 45. From this line here, basically from the x-axis to the
90?
y-axis. 90 degrees. So 90 over 360 times 2 pi. And we are going to stay with fractions. So again, if you wanted to, you could grab the calculator here. You could do 9 over 60. You could also see they're both divisible by 10. They're both divisible by 9. So the answer is going to be 1/4 times 2 pi, which gives you an answer of 2 over 4. I'm going to run out of space. 2 pi over 4. If you divide those both by 2, you'll get pi over 2. So one way of explaining how you get any angle on the entire circle, any of the angles you had to find today, is by using the arc length formula. I didn't bother going back after I did the arc length and dividing by the radius because the radius is just 1. And if you divide by 1, it doesn't change the number at all. Any questions about that method? The second way I'd like to think about it is fractions. So if this is 1 whole pi, my pre-calculus teacher in high school used to say it was a panzerotti, which is like a pizza folded in half, because I don't want you to think of the whole circle as 1. We're thinking of just this top half as 1. So this top half is 1. Okay, then we have 2 pieces. So remember fractions. The top number tells us how many, and the bottom number tells us what size. So we have 1 pi out of 2 total pieces that would make up the top half. That would make up 1 pi. So I took 1 pi here, and I split it up into 2 equal pieces. Remembering, if we go down to this guy, we always start here and we always go counterclockwise. So by the time I get to here, do you see how I have 1, 2, 3 of those same size pieces? And since 2 of those pieces make up a whole, that's why the denominator is 2. And since I have 1, 2, 3 of those pieces, that's why the numerator is 3. And this is in terms of pi, right? We're saying when we talk about a whole, we're talking about 1 whole pi. So that's why we say it's 3 halves of a pi. It's 3 pieces that are each half of a pi. So that would be a second way of writing your reasoning. And if my handwriting wasn't so terrible, I might add in some words, but all those things I just said would all be things you would write down. Any questions from either of those arguments? The only person I see is Kylie, and she shakes her head no. So it's the only feedback I'm getting, the only thing I can assume. Thank you.
I got a question.
Thank you. Yes, Justin?
So, because I know in the formula for circumference, there's always that multiply by 2, right? And I used to question that because I thought that it was basically, you was adding the radius by 2. I mean, multiplying the radius by 2. And I was wondering, if we're going to do that, why don't we just use a denominator? Not denominator. Why don't we just use the diameter instead, right?
Great question. Great question. Go ahead, but do you know why?
Now I'm seeing this. And so now is the multiply by 2 not for the radius, but instead for the pi, since pi actually equals 1/2 of the circle and not the whole thing?
No, you are correct. If we did in terms of the diameter instead of terms of the radius, then it would be like the whole circle, we wouldn't have to, could be pi. Yes, this recording will be there. The reason though, Justin, that we're going to use the radius and not the diameter, to be honest, and I don't want to get too deep in the weeds on this, but there's some like readings you can do that like way back when they first started talking about circles, people wish that they didn't discover pi. They like discovered 2 pi and like it was just one number. Anyway, I don't want to get too hung up on that, but you could think of it either way. But remember how this radius makes the triangle and the equation of the circle comes from the radius?
Mm-hmm.
So we have to think in terms of radiuses and not in terms of pies. I mean, not in terms of diameters in order to like do some algebra, in order to put this on a graph, in order to use the Pythagorean theorem. So we could have done all of this in terms of the diameter, but then when we went to put it on the graph, we would have had to cut everything in half again. So because of this triangle hypotenuse equals radius connection, right? And because really the definition of the circle, remember Olivia and Paul, is like all the points equally distant from the center. Honestly, like the people who discovered pi messed up. They should have thought about the radius and not about the diameter. So that's why there's a 2 there.
Oh, I see.
Other questions?
Nope. I just want to know where on Canvas will this recording be?
I haven't decided yet.
Okay. Thank you.